All right, folks, this is going to be an example problem about summing the forces on an object and using F equals ma. Here goes. A crate is pushed across the floor by a horizontal force of 100 newtons. The mass of the crate is 11 kilograms, and the coefficient of friction between the crate and the floor is 0.350. At what rate is the crate accelerated? First thing you do is draw your situation. My pen went goofy on me. Sorry about that. All right, draw our crate. Now I am going to put a dot in the center of the crate, and I'm using the dot to represent the center of mass of the crate. So we're going to have all forces acting on that spot. A crate is pushed across the floor by a horizontal force of 100 newtons. So there's 100 newtons acting this way. The mass of the crate is 11 kilograms, and I know the coefficient of friction on the crate is 0.35, and I want to know at what rate is it accelerated horizontally. Now the next thing I'm going to do is I am going to draw all the other force vectors that act on this object. So force of gravity is down, normal force is up, and it says there is a frictional force, and friction always opposes motion. So friction is going to be parallel to the surface and in the opposite direction. I am going to call the direction of motion positive and the direction opposite that negative. So that's the first thing I do. Now, when you draw forces, one of the things I want you to look for is most of the time I want you to look for this XY pattern. It might be scattered about a little bit, but this is what we're going to aim for most of the time when we're drawing our force vectors, or they're also called free body diagrams. So once I have my forces in place, next thing I'm going to do is I am going to sum the forces on my object in the horizontal direction, and I'm going to sum the forces on my object in the vertical direction. Now for each direction, left to right or up and down, I'm going to sum the forces. So I'm going to draw two columns. Next thing I'm going to do is I'm going to ask myself this question. In that direction, is this a Newton's first law scenario or second law scenario? Do the sum of the forces equal 0, or do the sum of the forces equal mass times acceleration? So horizontally, I am asked at what rate is this thing accelerated, so I know the sum of the forces horizontally are going to make this mass accelerate. Vertically, normal force, gravity, it's sitting on the surface. It's not flying up, it's not falling through the ground. So vertically, my sum of my forces are going to be equal to 0. Next, I'm going to write my equations. So here goes. In the horizontal direction, I called the force applied positive. So my force applied minus friction force, why is it minus? Because it's in the opposite direction, is going to make my mass accelerate. In the vertical direction, normal force equals force of gravity. So normal force equals force of gravity. Now that is a lot of the physics. Now what we've got to do is plug in the numbers we have and now solve for my unknowns. So force applied I know is 100 newtons. They told me that in the problem. Friction force, I'm not told friction force, but I know friction force is mu times normal force. So I'm going to replace friction force with mu times normal force. And that's going to make my mass, I was told it's 11 kilograms, accelerate. Now, do I know anything else in this? Yeah, I know coefficient of friction. So I'm going to rewrite it or take it down one more level. 100 newtons minus 0.35, that's the coefficient of friction from up here, times my normal force is going to make my 11 kilogram mass accelerate. All right, on the vertical side, now I have to stop here because I've got one equation and two unknowns. So what do I do when I run out of stuff to do? I go to the other column. My normal force equals force of gravity. Well, what is force of gravity? I know force of gravity is equal to mass times acceleration of gravity. So I am going to replace force of gravity with mass times acceleration of gravity. What is my mass? Well, my mass is 11 kilograms. What's the acceleration of gravity? My good old friend, 9.8 meters per second squared. So I'm going to pick up my calculator right here. You don't have to, but I'm going to multiply those two out, and I ended up with 108 newtons. Now that I have 108 newtons, what I can do with that is I can take this and I can put it right there in the other equation, and that's what I'm going to do. So I'm going to have 100 newtons minus 0.35 times 108 newtons, newtons, equals 11 kilograms times my rate of acceleration. 100 newtons minus, now what is 0.35 times 108? Well, 0.35 times 108 is 37.8 newtons, equals 11 kilograms A, and when I do the subtraction, this is going to be 62.2 newtons, equals 11 kilograms times acceleration, or in other words, acceleration is 62.2 newtons divided by 11 kilograms. And when I do the math, I end up with 5.65 meters per second squared. One final word before I leave this, and that is when I do problems this way, I am going to go nice and slow and deliberate through every step because I don't want to lose anybody. If you are smart enough that you can combine lots of steps in one, well, cool, and yahoo for you. But my job is to explain things carefully so people can follow. That will do for this time. Next time we're going to come back and do another one.